All right, so 3.7 is implicit differentiation. And the best way I can describe it, I didn't even look up the technical definition, is just taking the derivative of an expression with respect to a different variable. So what I mean by that is that up to this point, we've taken derivative, in other words, of x squared with respect to x. So the bottom variable always lets you know what you're taking the derivative with respect to. And of course, what's in the parentheses is what you're taking the derivative of. So if you're taking the derivative of x squared with respect to x, that would just be 2x. If you're taking the derivative of y squared with respect to y, then that would just be 2y. The same principles apply as long as you're taking that expression with respect to the variable that's in that expression. So now, if you have to take the derivative of y squared with respect to x, that's when we're looking at implicitly deriving the expression. All right. So what you would do is you would take the derivative of it as if it was with respect to that variable, and then what would be left is just dy dx. In other words, there will still be a piece that you cannot take the derivative of. So in other words, let me write it like this. I'll leave that one. Trying to see would be a good way. I don't want to go there. I think I'll just be making it more complicated than necessary. All right, so let's take the derivative of this y squared with respect to x. So the first part would be just taking the derivative of y squared with respect to y. Then you can multiply it times the derivative of y with respect to x. And this is the piece right here that we can't do anything with. So in other words, we just saw what the derivative of y squared is with respect to y. That's just 2y. Bring down the 2, subtract 1 from the exponent, and then there would be dy dx. And that's where you would stop when it comes to taking the derivative of it implicitly. Now we have other steps when we want to do other things, and you'll see in a second, but that's implicit differentiation. So you take the derivative of it with respect to it, the variable that's involved, and then what's left is the derivative, in this case, derivative of y over dx. Also, if you look at, let's say if we want to take it back to the original expression, dy and dy would cancel out, leave me with dy squared over dx, which is what I originally had. So that's the rationale and why we would do it this way. And just to reemphasize the process, if I had, let's see, I want to take the derivative of 5y cubed with respect to x, derivative of 5y cubed over dy, or with respect to y, then dy dx over here. Derivative of 5y cubed, bring down to 3, subtract 1 from your exponent, that's 2. And then dy dx. Like I said, you can't do anything with that. That'll be 15 y squared dy dx. All right. All right. So here we want to find the slope of the circle, x squared plus y squared equal to 25 at the point 3, -4. All right. So we want to find the derivative, I'll say, of the equation. All right. So we have x squared plus y squared equal to 25. So we're going to take the derivative of x squared with respect to x, y squared with respect to x, and the derivative of 25 with respect to x. Our variables match in the first term. Derivative of x squared with respect to x will just be 2x. Derivative of y squared, remember what we do is take the derivative of y squared with respect to y, so that's 2y. But because it's dx under there, you're still going to have dy dx left over. And I really don't have to put that multiplication right there. And then derivative of any constant, no matter what is respect to, is going to be 0. So next we will solve for dy dx, because remember that is y prime, that is the derivative of y. Go with that low. So we subtract 2x from both sides. Then we'll divide by 2y. And that'll be dy dx equal to negative x over y. All right, so before we finish off the problem, questions on how we got here. So now we'll substitute 3, -4. I believe that was the order pair. Yep. So we're substituting in 3, -4. So dy dx, x is 3, so that'd be -3 over -4 for y. So it's going to be 3/4, and that is our slope. All right, questions before we go to the next one.
That's the slope of the whole graph? 3 or
That's
4?
the slope of the circle at that point.
Oh, all right, all right.
Yeah. Mm-mm-mm-mm-mm. All right. So we're going to implicitly differentiate completely. Hold on 1 second. So to completely differentiate implicitly, we're going to differentiate both sides with respect to x, collect the terms with dy dx on one side, and then finish by solving for dy dx. And so, don't forget dy dx represents y prime, the derivative of y. So that's the goal. And if we do it this way, we'll be able to find dy dx, even if we cannot completely derive it initially, because we're doing it with respect to another variable. This would enable us to do so. All right, so find dy dx if y squared is equal to x squared plus sine of xy. So just like we did before with the x squared plus y squared equal 25, we're going to take the derivative of each expression with respect to x. All right. So first one, take derivative of y squared, which is 2y. Then you leave yourself with dy dx. Remember, that's always going to be the case if you take the derivative of a variable with respect to another variable. Derivative of 2x with respect to x is 2x. Now here, we have to remember our chain rule. We have sine, and then we have it. What's being applied by the sine is xy. So you have to take the derivative of sine, then take the derivative of xy. Derivative of sine is cosine, so it's cosine xy times derivative of xy with respect to x. So here we have the product rule. When we take the derivative of x, which is 1, and that'll be times y, plus the derivative of y, which is dy dx, times x. And you could have done that in any order, as long as you have, you could have said x, then times the derivative of y times the derivative of x. I don't even know why I did it in that order, but either way, you'll still get the same answer. So there's 2y dy over dx equal to 2x plus cosine xy times y plus x dy dx. All right. We can go ahead and distribute because we need access to this dy dx because we need to put both of those on the same side. So we'll go ahead and distribute. All right. All right, so the distribution, we have y times cosine x, and then here, all I did was put the x in front of the cosine xy, and that's sitting in front of dy dx. So y cosine xy, x cosine xy, dy dx. So you need to get this turned to the right side, so I'm going to subtract cosine xy, dy dx from both sides. So I got x cosine xy minus, well, x cosine xy dy dx, subtracting that from the term over there. They cancel out on the right. So I have 2y dy dx minus x cosine xy dy dx equal to 2x plus y cosine xy. So now we will factor out dy dx out of each term. So we'll bring that out front, dy dx. It's 2y minus x cosine xy equal to 2x plus y cosine xy Now we can divide both sides by that 2y minus x cosine xy. So I'm just rewriting stuff. So they cancel out on the left. What I'm left with is dy dx 2x plus y cosine xy 2y minus x cosine xy. And that will be your implicit differentiation. All right, any questions so far? Oh, that's 2x. All right, so they want us to find the second derivative with respect to x, of y with respect to x. Second derivative of y with respect to x. So the first thing we do want to do is just like before, take the derivative of each term individually. So we have 2x cubed minus 3y squared equal to 8. So we have to take the derivative twice. All right, so the derivative of 2x cubed, that's going to be 2, bring the 3 down, subtract 1 from the exponent, that's 2. Here, derivative of 3y squared with respect to x. So we have a 3 there, bring the 2 down, subtract 1 from the exponent, and then you're left with dy dx. Derivative of 8 is 0. All right. 6x squared, 6y, dy dx equal to 0. Go ahead and solve it for dy dx. I'm going to write it again. Subtract 6x squared from both sides. Divide by 6y. And dy dx is equal to negative x squared over y. So we're not finished, but that's just our first derivative. All right.
You forgot the negative in the 6y.
Negative.
It was minus 6y.
Oh, okay. Thank you. Thank you. Appreciate that. So, right, that'll be x squared over y. Good catch. All right, so we have to take the derivative of this again in order to get the second derivative. If we want to shorthand it, we always could write it as, let me write it down here. Y prime is equal to x squared y. So same notation. Or notation means the same thing, I should say. So y double prime means I need to take the derivative of this with respect to x. And I guess I could wrote it down lower. So of course we have to use the quotient rule. Just to keep our notes straight, I'm gonna call ux squared derivative of u. It's going to be 2x. V is y. Derivative of y with respect to x is just dy dx. And the quotient rule is v u prime minus u. Why is that not erasing? Okay. V prime over v squared. All right, so okay, yep. So that'll be y times u prime, which is 2x, minus u, which is x squared, times v prime, which is dy dx, over v squared, which is y squared. All right. So let's do this. Let's simplify it. That's 2xy minus x squared. I'm going to go ahead and shorthand that y prime over y squared. Go ahead and break this up. And also recognize that on the left side of this equation is y double prime. All right, so let's see, do I want to break it up? No, I'll just break it up for right now. So, y squared. All right. We can simplify it further. Oh, that y, one of those y's can cancel out. Leave you with just y. And then here, this stays the same. So this is what we have so far as our most simplified expression. Then we recognize that y prime is equal to x squared y. So I can x squared over y. Because it's not fully, not as simple as we could go as far as double prime is concerned, because you still have that y prime in there. And we already know what y prime is equal to. All right, so that's 2xy minus x to the fourth over y cubed. All right, questions on what we did? Let's see if we got another one. Good to go. Got one more example. Find a tangent. I ran out of room. All right, so find the tangent to the curve x cubed plus y cubed minus 9xy equal to 0 at the point 2, 4. All right, so just like before, find the derivative of each piece. All right, so that's going to be 3x squared, 3y squared, and since it's derivative with respect to x, dy dx, I can actually bring the 9 out front and just do the derivative of xy using the product rule. So derivative of x is just 1. Then you have dy dx plus derivative, no, got y derivative. Oh, I'm doing this wrong. Hold on 1 second. Come on. Eraser, messing up. All right. So let's go x dy dx plus y derivative of x is just 1. And derivative of 0 is 0. All right. So 3x squared, 3y squared, dy dx. Distribute the negative 9, so it's negative 9x dy dx minus 9y equal to 0. All right. So now I want to solve for dy dx. So we'll get each term that has dy dx on one side, the other terms without dy dx to the other. So I'm going to add 9y, subtract 3x squared. So I have 3y squared dy dx minus 9x dy dx equal to 3x squared plus 9y. All right, and make sure I got all my signs together. 3y squared minus 9x. So I'm good there. Then I had a positive 3x squared. So this should be negative. I knew I was missing something. This should be negative. So that means that'll be negative. And then I added 9y. Okay, I'm good to go now. All right. So now factor out dy dx. Using 3y squared minus 9x in parentheses. Divide by 3y squared minus 9x. These cancel. So dy dx is equal to negative 3x squared plus 9y. 3y squared minus 9x And if I wanted to reduce this, I can factor out a 3 on both top and bottom. Threes cancel. All right, dy dx equal to negative x squared plus 3y over y squared minus 9x. And of course, the order of those doesn't matter as long as x squared is negative, 3y is positive, y squared is positive, and 9x is, oh, that shouldn't be 9, should be 3. There we go. 3 is negative. So to figure out the slope at this point, we can use the point 2, 4 and plug them in. Hold on 1 second. All right, sorry about that. Had to click on this other thing, this other meeting. All right, so let's finish this off, plugging in 2, 4. So we're looking at, I want to go back, dy dx, and we're going to plug in that 2, 4. So that's negative 2 squared, 3 times 4, 4 squared, all right. All right, so that negative, be careful there, the negative sitting on the outside of that square. So that should be still negative 4 plus 12. 16 minus 6. So that's going to be 8 on top, 10 on bottom. And that will be 4 over 5 as your slope. All right, so that's our slope. And so now we'll use point slope formula. Y minus y1 equal to m times x minus x1. And our x1, y1 is coming from the point 2, 4 that we already used. That was 2, 4, right? Yep. So that's y minus 4 equal to 4 over 5 times x minus 2. Go ahead and distribute. 34 fifths x minus 8 fifths, which is 2 times 4. And then add 4 to both sides. Y is equal to 4 fifths x. Here you got 4 over 1. That's going to be 20 over 5. So negative 8 fifths plus 20 over 5 will be a plus 12 over 5. And that should be our tangent. Okay. Oh, that's good to go. All right. Questions on that before we look to close out?
Nope, I'm good.
Okay, cool. So try this out. I'll post this homework. I don't think I posted this one. I posted up 3-6. So, try this stuff out. See if you get stuck. Always feel free to email me or, wait till next class to ask questions. I may cancel class on Monday just to, you know, I just got to see what people are doing. I haven't looked since the last time we talked. So see if by the weekend people have gotten in there, but it's kind of hard to keep pressing forward if only one person is doing like majority of the work. You know what I mean? So it's kind of
Yeah, I still haven't taken the chapter 2 test. So I plan on
yeah,
doing that this weekend.
yeah. So just look out for the email. I may cancel class and then just have class on Wednesday. So, but outside of that, I'll post this and talk to you next week, man. You be safe and have a good one.
All right, you too.
All right, take care.